Good morning. It's really great to be with you this morning. You may be wondering why the title on my talk is Life on the Edge. So I'll try to convince you why this is a good title. If you think about your homes are actually edge of the network, whether it's transportation network, utility network, or in the, of course, internet. If you think about your accessing healthcare, so your doctor's office and hospital, they are edge of the healthcare networks. Similarly, if you think about factories and farms, they would be edge of your production or food networks. So the key is how does our life at that edge has evolved over the years. If you look at the previous technologies, and I'll share some of that in a minute, that has tremendous impact. The one example I like to give you is growing up in India. If you needed a phone line, wide line, there was a wait time, depending on the city, 10 to 15 years before you could get a line. And then cellular technologies were evolved, and India was leapfrogged from constraints of the wide infrastructure, which the country would not have been able to put it in to support billions of people, more than billion people that we have. And today, you have more than billion cell phone in the country, in India, and everybody's connected. So if you think about, for the audience in this room, and if you think about your smartphone, all the services that you access to, from your smartphone, imagine a day without a cell phone. So what I'm hoping is that the next set of technologies that we are working on, and I called it AIoT, so when you combine the artificial intelligence and IoT, what type of things you could deliver. But some of you, like me, may have been involved in IoT for a long time, and then IoT has a long promise, but if you look back, our scorecard of delivering the promise that we made to our customers, or the customers expecting ROI, has not been proven out. So what has been the cause of us not being able to deliver the promise of connect everything to the internet and lots of good things will happen? It's not that we haven't made improvement. There's quite a bit of improvement, but as I share with you, we haven't really done enough. So the challenge for us is what is missing and what can we do? So as I mentioned, if you think about the impact of IoT, and obviously the IoT is a buzzword, includes a lot of things in it. According to this study by McKinsey Global Institute, expected value created by IoT is could be up to more than $13 trillion per year. And if you compare this with last year's US GDP, or US economy, was about $18 trillion. So it's a big deal. But at the same time, if you look at the range, the lower number is about $4 trillion. So there's a big gap between, there's a large range. And so what's the cause of this uncertainty? Why we have not been able to deliver? So obviously, linking the physical thing is one thing, but what else is missing? So I would like to take you for a little bit of a journey on IoT, especially from my perspective. I have watched it for a few years. So the first thing, first problem, or first phase of IoT journey was how do we connect these things? Different things from cars to different embedded systems. And then the challenge was many of these devices have BOM constraints, so can you have a solution that fits into the BOM constraints of the device? The second challenge was, does it meet the wireless technologies, different wireless technologies that needed to connect? And as you know, whether it's a personal area network or local area network or wide area network, like narrowband IoT mentioned previously, now we have a variety of these communication protocols or communication technologies make it easy to connect these things to the system. And then finally, some of the devices are battery operated. So if I connect these things to internet, my battery would last the way it was previously done. And so many of you in the room have contributed to the silicon that now makes it possible to connect. So I think it's no longer a challenge that we can't connect things. Then second thing is, if you once you have connected these large number of devices and they start collecting the data, what can you do with it? And the promise is the device or the system, what it does day one, it should do something better day two. And that means it's not about static programs that was built into these devices. You should be able to go back and change the behavior of the system. And hence the second part, or second phase, which I think we are in that phase now. It's easier to program these devices. You can update firmware over the update these devices. But one of the most interesting things that I worked on is not about just individually programming the device, but if you look at the IoT system end-to-end, which involves the devices, the gateways, and then cloud, how do you treat it as a complete system and then program it? And I'll talk about a little bit later in the talk how this is also pretty much done. The third phase is if you're going to have 30, 40, 50 billion devices in the next few years, pick whatever number that you believe in, the question is, if it's going to generate this staggering amount of data, if you think of any sensors, it's just spitting out whatever it's sensing every millisecond, microsecond, however fast you are collecting the data. So how do you make sense out of this data? Because customers are able to collect so much data that was previously not possible. So these systems now need to somehow automate it. And I think that has been one of the missing link, is that if I had going to write the static programs or static rules to handle this data, I would never really able to handle the new data that I have not seen before, and not learn from and improve the system. So I believe the challenge that we face as industry, and then there was many examples Yankin presented when it comes to AI being used in many different places. This is where I think we have our challenge in front of us. We can create solutions that helps our customers achieve their return of investment or the promise that the IoT industry makes. Okay, so I have been using the word edge or life on the edge very loosely. So let's define it a little bit more precisely, what I mean by edge. And so for simple picture, I put cloud or the data centers where you have this hub or center of the information systems at the very left, or left of me and right of you. The very first thing that edge could be defined as what's called point of presence. So these are places where cloud service providers like Amazon Web Services puts systems to give you the first access, and typically these are connected through leased lines or the dedicated links between the point of presence, where you can host parts of the services. Next up is we all access the wireless infrastructure, so think about cellular towers or substations, where these first concentration of the users comes into the picture. For telecom industry, that will be the edge. Think about racks of servers in the factory setup or remote location like oil and gas exploration or mining setup factories where you would have local intelligence. That could be also described as an edge. Compute on the cars or any other mobile device could be considered as edge. And as you can see, as I going towards the other end of the spectrum, things becoming smaller. So things like gateways on your home and the buildings where they collect the information from sensors. And to the very end, some people can also call the endpoints, in this case, robots or very other end of the connection could be an edge. So all of these could be edge. It depends on the application and depends on what you're trying to do. All of these could be characterized as edge. So what are the driving factors for us to consider how does edge plays into the larger solution space? So for simplification, I created kind of the two end of the spectrum. I put data centers or cloud on the one end and all the other edge examples I gave you on the left. So some of the principles that we like to follow These are fundamental principles. We believe these are applicable in all scenarios, and we tend to call them laws. And so the first law is law of physics. What it means in our context is the speed of light is constant. So depending on the distance from where the data is being generated and where you want to process them, that'll incur latency. So depending on the requirements for your application, you have to decide, should I very one end of the edge to somewhere in the middle to the very right in the cloud, where do I process the data? And obviously there are examples like if you're having autonomous driving car or robots, they need to take an action on the data immediately. So that means the data needs to be processed right there. It can't take even milliseconds of delay. The second factor that we would like to see that one would have to consider is the data has weight, and not all the data is made the same way. Not all the data has the same value. So you have to decide now for within the budget of your solution that you're trying to put together, what data to process locally, store locally, and what data to take it for the global use to the cloud. And then the third categories of factors that you may want to consider is the regulatory requirements. So in this country, if you are dealing with healthcare data, then you have to be bound by the HIPAA laws. Other countries might have laws where you can, citizen data, you are not allowed to take it outside of the country. So depending on what you're trying to do, this will be the third constraint. So together, and a few other constraints that you will see, okay, how do I design my system, and how do I decide where to process the data? So one of the things that I started my commentaries is all the things that I've said so far generates lots and lots of data. Okay, as you're creating lots of data, how do we make sense out of it? And you know, we have been talking about artificial intelligence. Until now, if you think about the artificial intelligence or machine learning examples that you may know, are driven from the cloud, whether it's the searches, the recommendation. So far, it has been difficult to see how we apply some of the same capabilities down to the devices that may be constrained. But fortunately, both advancement in the artificial intelligence, different frameworks that have come, specifically frameworks designed to deal with the data, like Chainer is one of the frameworks that designed to deal with IoT data, to the folks in the room who have contributed to make it possible to bring the machine learning to the smaller devices. And we saw an example earlier today, the machine learning in the ARC processor. So, but how do you actually put it together? Now, yes, I can do some of the machine learning inferences on the edge, but how do I put together? Typically, what would you would start with some set of data that you already have. So what I call it, collect the data and then train the model. And once you have a model that you want to deploy, you would want to deploy in the production, which is the second stage. And based on the data that you're seeing it now, you would infer or predict what are you looking at and what are you seeing it, and then decide what action you need to take. And in some cases, you may not know exactly what the optimal prediction or optimal action you have. In that case, that new data feeds back into the loop. So the idea is that what I talked about earlier, that your system should learn and do something better as you go. As at a highest level, the IoT is about two things, or the promise that we deliver to our customers is that either they can have the operational efficiencies. Whatever they're doing today, they can do it much better, faster, cheaper, with less resources. And then second thing is they're able to deliver some new user experiences or new capabilities that's not possible. And this is within the system, that without truck roll changing of the system. And this virtuous circle helps you keep the system do more and more. All right. I would argue with you. I would make this claim that we talked about why IoT progress has been slow, and what has been missing. At the same time, if you think about AI, AI is the next frontier, I believe, is bringing those intelligence to the devices, to the edge. Sometimes these are constrained devices. So it's a marriage between the two technologies. And somebody, it's not I won't take the claim for AIoT, but somebody coined this term AIoT. What it means is when you combine the capability of artificial intelligence with IoT, hopefully the things that are not possible before we can be done much better. Now, in terms of the impact of these technologies, it spans across all industries, and I'm showing some examples here. I'll walk you through some of the examples that customers are using AWS technologies. I'll pick the ones I believe some of the pressing needs or challenges of the world would be the food or agriculture, energy and water conservation, and then finally the healthcare. So I'll take a few examples out of those. Okay, so let's start with how can we do better in growing food. So the first example comes from a company called Yanmar. It's a Japanese company, manufactures lots of different diesel engines and equipments for industry use, including in agriculture. And they were one of the early adopters of some of our edge computing technologies and machine learning at the edge. And then the problem they were facing is as they were trying to develop solution for the greenhouse, they wanted a system that could optimize the delivery of water and then environmental support, including how to keep the temperature right and the costs associated with it. And you could have lots of sensors and many other ways you could do this. The approach they have chosen is they have put cameras in the greenhouse and locally analyzing what the images they were seeing. They were able to predict the growth cycle of the plants and also the needs, whether the plants needed more water or the temperature setting. All that analysis they were able to do through this. Locally, the models obviously were trained in the cloud and deployed using our technology called AWS Greengrass to the device. The impact that they have with this is previously they were sending all this data through the wireless WAN connectivity to the central place to analyze it. Now they don't have to do that. They can also reduce the cost for their own customers because they can optimize how much water and how much energy they would need to operate this greenhouse. The second example comes from a company called Paralytic. They build health soil sensors, and they have with the network of sensors. One of the problem they were trying to address is obviously delivering the efficiency to their customers, which is the farmers, but also prevent these chemicals seeping into the soil, into your groundwater, or on the surface water. And so they were collecting this data from various different sensors. Obviously, there are some outliers that they wanted to understand. So what they wanted to understand was, as all this data coming from this network of soil sensors, how to predict what's going on in the field. And they choose our service called AWS IoT Analytics. In this case, they were able to sort out what data to actually include in their analysis and what are the outliers. And obviously, the impact is beyond the environmental consideration they wanted to deliver to their customers, the operational efficiency and better yield for their crop. Okay, second set of examples that come from how could you take small steps towards better use of our existing energy or the limited resources like water. So I'll start with the electricity or energy example. So Enel is one of the largest electricity utility company. They serve about 61 million customers. And one of the things they wanted to do was they wanted to understand from the production and consumption and also what customer experience they wanted to deliver. And so they wanted to build a system where they could standardize gateways. They wanted to put it in the houses or in what's called substations, and also the sensors and gateways they wanted to put in production where they can understand how the production of the energy production was going. And so they chose AWS Greengrass as a common platform and AWS IoT as a cloud platform. And their goal is to not only understand the real-time demand. You have the artificial intelligence, you know the historical demand, and then they can actually predict how much electricity they generate, also creating incentive to the customers at what point it'll be optimal for them to use the different energy. The second example is my favorite. I'm one of the customers of Ratio. Comes from a company called Ratio. They make smart sprinkler control. And as they started, they had a limited resources. They had a good idea, but limited resources in terms of understanding the hardware, the cloud platform, the machine learning. And so they chose us early on as a platform to build their IoT systems. And so the sprinkler system is smart in a way that you could point it to a weather station close to you. And in my case, I just simply remove the old system that you had to manually program. With the new one, now you can just use the smartphone to look at it. But the way it works is you point it to a weather station. It can adjust the timing that's needed for the different type of vegetation. It understands the different type of watering needs, from grass to shrubs to trees. And it automatically adjusts, and the days where it's rain in forecast will stop. And they have been able to save millions of gallons of water for their customers around the world. One of the things that I really like is it just adjusts and then it stops, because I don't have to worry about it whether my sprinkler is running while the rain is on, for example. Really, I like their device. Lastly, all of us want to have a healthier life, and so what, as an industry, what small improvements can we deliver? So my first example comes from a company called M3 Health, and these are the technology provider for the healthcare and life service industries. And these are the customers that these are one of our customers, don't have a lot of technical know-how in terms of what is a device, what is IoT. But the problem they are trying to solve is increase their communication with their customers. And so we have a service called AWS IoT One-Click. It's meant for customers who do not want to deal with understanding how to build a hardware device and how to deploy. So AWS IoT One-Click service comes with pre-provisioned devices. And in this case, they use one of our device to quickly deploy into their customers, which they can use to communicate. And one of the example mentioned here is if one of their customers wanted a sample drug, and they can simply say, okay, we are missing that sample, and can you deliver? The point is these customers are looking for solving the problems, and then sometimes we talk more technology than solving problems. This is the simplest way we believe some of the problems could be solved. And then the last example is from Philips Medical, which I don't believe it needs introduction. But one of the things they were trying to do is as they're trying to upgrade their medical devices and make them connected to internet, they wanted to make sure they are secure, they're reliably delivering what they were supposed to do. They can update them if there are problems found. And also they wanted to control how the data generated within those devices would be routed or shared with other devices or other sources. And so they use our service called AWS Device Management to build the core IoT device platform. And they would like to take it from there, but as you can read the comment from the customer. All right. So hopefully I gave you a flavor of small steps taken by some of our customers in solving their problems from different industry. So let me tell you under the cover what are the capabilities and services that we have. So I'll start with our services in AI and machine learning. So first is, as you might know, Amazon has been in existence for more than 20 years. And we have been using AI for the amount of the time that we have been in existence. And some of our retail consumer business that some of you may be a customer of, or use AI as a fuel for constantly delivering the better experience from you. So starting with simple things like personalized recommendations. You may have seen when you buy a product, these are the other products the other customers bought, or your daily deals or personalized recommendation that you get when you log on. That's fueled through AI. Our fulfillment center uses the robots. And one of the things these robots do is they predict what product's going to be bought by one of us, and load them in this actually carry the racks around to the associates. So preload those products onto the racks, and then they go to the associates. So associates don't have to go from rack to rack looking for the products. These robots deliver those products for picking and packing right to those associates. Amazon Prime Air obviously will use quite a bit of artificial intelligence to do the air delivery. You maybe have first-hand experience with Amazon Alexa, which has really created a natural language processing and voice interaction to the devices much more easier, and you may have first-hand experience. You could have interaction with the devices, ask questions, obviously, you can do things. One of the interesting things that have happened with Alexa voice services is about 20,000 different devices integrate Alexa voice services today. Anywhere from the devices that go in the consumer home, not necessarily just our Echo device, which is the first Alexa device, but in the industrials and in many other examples. So, and again, the engine that behind that is deep learning and AI. And then finally, one of my favorite example is Amazon Go. It's a store in Seattle. And the new experience that we deliver here is you can just simply go to the store, pick whatever items you want, and just walk out. And I'm a frequent user of the store, and my grocery time is less than 5 minutes on a typical day. And so what's behind that is obviously there's a lot of technology that makes it happen. You simply, when you walk into the store, you use the smartphone to check in, scan it, and beyond that, you don't have to do anything. You simply walk out with all the stuff. Sometimes we call it "let's go shoplifting," but it's the kinds of things that, as you can see, that's are possible with the technology. So let's look behind the scene how we are making it possible. So first is the lowest level of an infrastructure layer. So if you're developing your AI application in the cloud, obviously there are cloud computing capabilities like EC2 GPUs and CPUs that you can get. But if you're deploying, some of the examples I gave is machine learning at the edge, which could use AWS Greengrass or some other edge computing capability. Beyond that, the very first software layer is what we call it frameworks and interfaces. And these are for practitioners of machine learning. These are experts. They understand how to take the data, create a model, and define which framework to use. And so basically all the muck that goes around in putting it together they are meant for those people. There are not in a, we don't have a lots of those people. And one of the things that if you look at how these will go from here, we have, Amazon has thousands of these experts, but not many companies would have those experts. For them to use it, it has to be better than just these frameworks, interfaces that everybody has to understand. So the very first step that we are delivered late last year is some kinds of platform that will be meant for developers. Again, this is not for consumption as a ready-made service. And I'll go into the details of Amazon SageMaker and AWS TeaPlant. These are the tools for developers to go build their technologies or build their own machine learning application. To the very top are what we call it. There are some customers who are saying, here's the image or here's the video, tell me what you see, tell me exactly what you infer, and then help me put together an application around it. So we have a service called recognition, both recognition in a still picture and then recognition video, which you can use as a starting point to build your computer vision application. and start doing this very quickly. Poly is our text-to-speech or human-like speech capability. So if you wanted to build a application that can talk, one could use Poly. Transcribe is converting your speech to text. Translate, obviously translating between one language to another language. Comprehend is a natural language processing service that helps you gain insights and relationships in the text. So you can comprehend what is this piece of text says. And Lex is a service that lets you put the voice interaction capability into your application. It uses the same engine behind the capability as our Alexa voice services. So similar to Alexa voice service, you want to do it completely on your own, you could use Lex. So those are the 3 layers of different capabilities we are putting together. But I want to get back to the point I said, how do we make it easier for developers? So if you are a developer of AI and machine learning applications today, you have to deal with the complexity of these steps. The first is you have to decide the data that you have, what part of the data is important for creating that model. Then you would choose a set of algorithm and framework to put together your model. And once you have set up the model, then it requires the tuning. So you'll run through the data and see whether the prediction that you wanted are accurate. And so this tuning is typically trial and error, quite compute intensive, as well as human efforts are required. So you need to have a time and expertise to do this. And then finally, once you are satisfied with your model, you're going to deploy in a production in a way that it can scale. And then there's another set of challenge comes in. Okay, how do you scale as your business is scaling with it? So to simplify, we introduce a service called Amazon SageMaker. So the first 2 steps, which is part of building the model, we provide pre-built Jupyter notebooks, which basically a logical way of you deciding and describing what your machine learning application looks like. It also lets you visualize and look at the data to see which is the data is more important to you. And finally, there are 10 plus different algorithms that we have optimized for specific applications that you want to build. So it makes your first step of building the model very simple. The second step is training. So once you have built the model, with one click you can start training. Also, you could optimize to the target hardware. So if you want to do it in the cloud versus you wanted to do on the edge on a green grass, it lets you optimize the model according to the target environment. And then finally, if you want to deploy in the cloud, this service lets you deploy with one click and also gives you the managed hosting service that scales automatically as your application will scale. And I'll get into the little bit later in the presentation where I'll talk about how to deploy these on edge using Greengrass. Okay, so let's quickly cover some of our IoT services behind this. So starting with the edge or things, we have a service called FreeArt, a product called FreeArtos, and some of the folks on Arc probably know about it. Amazon FreeArtos adds additional capabilities. I'll get into that in a minute. On the gateway or a edge side or the edge computing side, we have a service called Greengrass. We also offer IoT SDK if you're not using one of these two. In the cloud, the very first service that lets you connect millions of devices called AWS IoT Core. So you securely connect and scale around the globe wherever you are running your application. The service and IoT Core is the basis or foundational block for building rest of the capabilities. And one of the things that the example I gave you on Philips, they use our service called device management. And this device management lets you manage a fleet of devices, logically control them, both in terms of keeping them up to date or create any other set of jobs. And so this comprehends it makes it much easier as your deployment will increase. And then the second service behind it is called IoT Device Defender. And think about now you have a large IoT system. You don't know which device is actually secure, what actions it have taken. So this device lets you use the machine learning to understand the behavior of your system and which one of the devices may be out of norms. And then finally the service called Analytics I covered a little bit earlier. Think about the data that you're collecting from different sources. Obviously, these data in different format. So how to make sense out of it, how to clean it, and how to create sense out of those data coming from different sources. So IoT Analytics lets you complete it. And for the customers who do not want to deal with this complexity, as I said earlier, from things to the cloud, we have a service called IoT One Click. In this service, basically, we worked with the device manufacturers to have a ready-made devices that are pre-qualified, pre-authenticated with this service that customers can just deploy them in scale. Okay, a little bit more about Amazon FreeArt, maybe interest to some of you here. So Amazon FreeArt as a kernel has been in existence for a long time, and I believe many of you may have been exposed to it. What we have done with the Amazon FreeArt is added the capabilities to make it IoT friendly, both in terms of how do you connect locally to using different protocols, you connect to the cloud, and also make it easier for embedded programmers to understand how to actually interact with the cloud services. So we have libraries around that. Obviously, security is very important, so we support both multiple security protocols. And recently, we added the over-the-air capabilities, including signing, because one of the things that you want to make sure is, as you're updating the devices, that code came from a known source or trusted source. So with the signing, you could ensure that devices are updated with the software that you want it to be updated. The second service is for so while FreeArt is meant for the microcontroller-based devices like sensors, Greengrass is meant for your Linux class devices that can scale from gateways to high-end servers. And one of the things we have done is to make the Greengrass platform easily programmable from the cloud. So the local action is written in a service called Lambda, is one of our services. It's based on triggers, and Lambda service can scale to the level your application can scale. So that local trigger, so you are looking at the data and then how to decide what to do with the data, syncing the data from this device to the cloud. One of the things Greengrass does is it runs its own its own certificate authority to manage the devices locally, and it can rotate the certificate and so guaranteed and issue the certificate and guarantee those your complete IoT system on the edge is secure. We have a capability called local resources, and we talked about machine learning in the beginning. So if you have a GPU or FPGA or other hardware capabilities and you want to control which program should have access to it, or camera, and Greengrass lets you define and control, have a final control over which application has access to these resources. Protocol adapters let you add new protocols that we don't support, and obviously over-the-air update. One of the key points that I want to make here is what we were trying to do is create this system programmable as a unit. You think about the edge devices and then the cloud, and we picked some of the high-level languages like Python, Node.js, and Java. And these are not the type of languages you hear from the embedded programmers, because they will usually C, C++. But this layer lets cloud programmers now program these edge devices. So they write the code and test the code in the cloud using the Lambda service, and we run the small miniature version of that Lambda service or runtime in the device that lets you change it. And remember, we talked about the virtuous cycle. You start with a certain capabilities and application, you learn, and you want to update it. And this is how you can update the device capability. Okay, so how do we combine? I promise I'll tell you how to apply the machine learning and the green grass. So using the capabilities of Amazon SageMaker, you will build and train the model in the cloud. So one of the other things in the SageMaker is Greengrass service running in the cloud can detect the changes in the model that you have deployed. And if there's a new model available, it can automatically, or you can decide when, it can pick up that model and then deploy it on the devices. Once this is deployed, obviously you can, along with the inference application, you can execute locally and take an action. And this whole process could be automated, and so one of the things we have tried to do is to make it extremely easy for Greengrass developers without knowing a whole lot about SageMaker, and somebody else develop the actual model. So in typical setup, you would have machine learning experts may not necessarily be part of the same team that is actually managing the edge deployment. And so this makes it easy for the two teams to work together and make the contribute towards the results together. The other tool that I quickly mentioned, didn't go into the detail, is AWS TeaPlant. And it's available on Amazon.com if you're interested in experimenting with it. It's not a video camera, and though it comes with a high definition video camera in it, but this is meant for developers. So you can use this device without understanding the frameworks, the different algorithms and tools. You can have your first computer vision or machine learning application running on this device very quickly. So it integrates the Amazon SageMaker, so you have a console specifically dedicated to deep lens, and then the Lambda is the way you develop the application. One of the other things this device does is it comes with the Greengrass preloaded, so all the IoT applications that we talked about, you could actually experiment putting those applications as well. It's very easy to get started. There's lots of sample projects that we make it available as part of this product. You could customize it as you learn, or you can completely create your own projects. And we believe this is a great way to get started on machine learning, so you don't have to really understand various aspects I spoke about earlier, but try your first experiment or first machine learning examples very quickly. Okay, I mentioned few customers in my presentation. This is another small list of customers. We have customers from across all the industries. And so I welcome opportunity if you're interested in a specific industry and specific example you want to learn. Me and my colleagues here will be happy to get into the additional details. One of the very strategic things for us is the partners. And these partners help us bring various parts of the building blocks to put together a solution. We have partners in technology, system integration, hardware, software, device manufacturer, silicon vendors. Many of you are represented here. And our goal is to make these things for the customers or developers, make it easy to find these things and start building their application quickly. We are heavily investing in this, and so one of the things I invite you to, if you want to interested in finding out what is AWS Partner Networks and what are the benefits of joining it, I have colleagues Joe Zalokar and Tim Madison with me here. So among three of us, you can reach one of us to find out more. Okay, I also want to say a few words about our host today. Synopsys have been worked with us from the beginning of IoT journey back in 2015. Initially, they helped us put together some starter kits. And I understand they're working they have been FreeArtos customers, so our FreeArtos has been one of the popular choices for Arc developers. And now Synopsys is working on porting Amazon FreeArtos, and I understand it'll be available to you end of this year. So beyond this, we are also expecting with you and then Synopsys to have partnership in other areas, whether it's the artificial intelligence or edge computing. So we look forward to those conversations. Now, I covered a lot of ground very quickly. So let's recap at the high level. So if you were trying to build an IoT application or AIoT application, we talked about a number of edge services we offer to the very right of me, including the IoT device SDK, Amazon FreeArt and Greengrass. These are the things that you would load on the devices. In the cloud, we talked about the IoT Core, device management, device defender, and analytics. And along with the rest of the AWS services, I covered SageMaker, but there are many others are listed here, whether it's the storage or compute. So when you're trying to put together your enterprise-grade application, you need few other services from AWS to put it together. So we have end-to-end capabilities for you to quickly put together application, AIoT applications. Along with we have a number of partners, whether these are system integrators, technology partners, hardware and software partners. They help you and your customers find the building blocks that needed to put a complete solution together. So let me come back to the point where we started. We started with what is happening with the IoT industry, and then for the last few years, while we have all worked very hard, the results are not for our customers have not come as fast as we have hoped. The promise of IoT that we delivered, and so we believe combining IoT was missing AI, and AI's next frontier is IoT, because for AI to go from cloud to solve some of the tough problems at the edge, whether it's the autonomous driving example we saw earlier, or your factories, your mines, your homes, for them to be intelligent, I believe together we can create this virtuous cycle. You start with some understanding, and the system is evolved. The capabilities the audience in this room can help put together is make the edge systems more AI capable or more easily accessible to the developers as well. So hopefully you're with me that in terms of what is AIoT and then how we can help our customers. So with that, I'd like to thank for your time, and thanks for Synopsys for inviting me, and have a rest of the good conference. Thanks a lot.